Ladies and gentlemen, hello and welcome back once again to the briefing room. It's Tuesday at 4 Eastern. That is when we run this show, as many of you now know. We actually do several different shows here at the Bloor Group. Of course, the briefing room is Tuesdays at 4 Eastern. Yours truly does DM Radio Thursdays at 3 Eastern. So if you've never checked that out, do a Google on DM Radio. That's a show I do for Source Media and their information management magazine. It's really good stuff. In fact, we're closing in on 5 years. It's another 5 or 6 months or so from now. We'll be at 5 years of doing DM Radio, so we're very excited about that. But this is, of course, the briefing room. This is where we pair analysts with innovative vendors to figure out what's going on, what they're doing. So let's start moving some of these slides. So there's a slide about yours truly and enough about me. The mission, as many of you now know, in the briefing room is to reveal the essential characteristics of enterprise software. And so the way we do that is we plan out a series of events. We invite vendors to participate in the show, obviously. When they agree to, we go out and find an analyst who knows a particular space pretty well but has not recently been briefed by that particular vendor. So the analyst and vendor do not coordinate before the show, which is really what makes our show different from just about anything else you're going to see out there in the real world. And the idea behind doing it that way, quite frankly, is because we want to expose that natural kind of conversation that occurs between an analyst who follows a particular space and a vendor who is doing some interesting stuff. I will tell you that one of the best components of these events is you, the audience out there. We get awesome questions from our audience. We get very, very detailed questions. I can see some of the folks in the audience room already today, and I know we're going to get some good questions because I recognize some of those names. But so the whole idea is to really get down to brass tacks and understand what are these technologies, how do they work, why were they designed a certain way, what are their key use cases. As many of you know out there, software can be used in any number of ways, but there are certain ways that it really should be used, and there are certain ways that certain technologies should not be used. So we're trying to get to the bottom of all that and figure out, for your benefit, what to use and when. So we do a different topic each month, and the idea there is we want to give you, the end user, some apples-to-apples comparisons within a particular space. Because the bottom line is if you're about to go pull the trigger on some enterprise software, you know for sure that's a serious decision, and there are going to be ramifications of that decision. So you want to make sure that you fully understand what it is that you're buying. Don't just go by what you see in the brochure or what someone told you. You really need to dig into the weeds and understand what's going on under the covers here. What is this stuff actually doing? How does it really work? So that's the mission of the show. So data integration, such a fascinating topic. I've been kind of amazed at how the term, the moniker data integration seems to be fading a bit, which I find rather ironic because it is certainly not the case that the need to carefully and assiduously integrate data has gone away. I mean, quite frankly, there are more data types, there are more data speeds. We keep hearing about velocity and volume and all these things. And the fact is, that challenge is still there, and it's not ever going to go away. I mean, I'm sort of an old-school software guy, so I really like to understand what the code is doing underneath all the veneer, if you will. I want to understand how to fix things. And so in order to do that, you really have to pay attention to what's going on. So that is the purpose of this show. And now the costs of data integration are high, and we say in here that they're rising. Obviously, that just depends upon what you're doing and what you're trying to accomplish. But the bottom line is that this stuff is out there everywhere, and these systems are changing. I mean, even platforms that we use, like WebEx, for this show, sometimes they change the data model. They change some part of that application. And as any of you in the real world of information management know, when something changes in the architecture of an application, well, that changes a lot. If you change a data model, that changes things. And staying on top of these changes, I would argue, is going to be the big challenge going forward. So our analyst today is Rick Sherman. He is one of the busiest consultants I know. He has been in this space for more years than I'm sure he wants me to mention specifically, but he's always on a project. He's always working, and we're really glad to have his experience in here because, let's face it, the people who are out there actually working on projects, they're the ones who know what's happening, how things are working, and frankly, what's not working. So Composite Software has been in the briefing room before. I'm sure some of you have seen them. It is enterprise-class data integration. It's data virtualization is what it is. And I, for one, see data virtualization, or as some call it, data federation, we'll try to get into what those mean during the show, as a growing trend, quite frankly. And I think it's going to be used increasingly over the next months and years to deal with issues like metadata management and semantics, to deal with data provisioning, to deal with issues even like compliance, as you increasingly see organizations circumvent that traditional route, which is rather cumbersome, of building a data warehouse, feeding the warehouse, building applications on top of that warehouse like OLAP cubes and so forth. As you see organizations go the data virtualization route to either supplant or complement that kind of environment, I think you'll see this whole discipline become more prominent and more refined. So David Besemer is the CTO of Composite Software. This guy knows his data virtualization, so we're pleased to have him in the room today. And what I'm going to do now is I'm going to actually hand over the keys, and David is going to do a desktop share, or actually an application share. And there you go. So David, the floor is yours.
Thank you very much, Eric. Take a second here and get my slides up. Okay, Eric, can you see my slides?
Yes, I can.
Excellent. Okay, so as Eric said, I'm with Composite Software, and data virtualization is the infrastructure software that we build and sell. And over the years of doing this, we've discovered that in addition to sort of normal business intelligence and data warehouse augmentation projects, we started to see more and more usage around analytics. And all of you who are listening, of course, know that analytics is different and unique. And so it's interesting for us to look at how data virtualization can help fuel some of the unique data needs of analysts and data scientists. The interesting thing about the analyst landscape is you usually start with the tools. People have their own favorite set of tools. Some of them are for manipulating the data and mining the data and maybe reformatting or torturing the data, if you will. And other tools are for visualizing the data or visualizing some results that you've created with your analytics. And obviously some of these tools will go back and forth. Some can do both visualization and manipulation and mining. But the interesting thing that we've found is that most analysts use a collection of these tools. And so it's not just one tool, but they may have some Excel spreadsheets. They may be doing some visualization with Tableau. They're doing some data manipulation with SAS. And they're essentially taking a toolbox full of different kinds of tools for different parts of the problem and applying them to the problem. Now, the other thing, of course, is that analysts are much less confined by where they get their data. And in fact, oftentimes they go way outside the boundaries. So, of course, they're getting data from their traditional enterprise sources. And you can see here on the graphic we're representing both internal enterprise sources like a traditional warehouse, say Teradata, or some operational sources like SAP or Oracle. But they're also starting to get data more and more from cloud-based sources that their enterprise has started to use, like Salesforce and maybe NetSuite. And now, of course, new NoSQL/big data sources like Hadoop, because they're potentially using those to do a different kind of analytics using MapReduce. So even within this one category, there's a pretty big variety of data that analysts need access to. Then, of course, there's perhaps their most innovative data source of all, which is the files and other types of data that's already on their desktop machine or their laptop. Analysts obviously have the ability to work with data in a variety of ways and often spool that data off and have their own spreadsheets and spread marts that they're working with data. So there's a tremendous amount of source data that actually exists on the computer that they're working with. And finally, an emerging area for data usage is really the public data sources, some of which you have to pay for, some of which are actually truly public and free, available on the internet and in the cloud. But more and more, data scientists and analysts are using this publicly available data to augment their research to try to reach whatever conclusion or answer they've theorized. So when you look at this landscape, I know that there's a lot of logos on here, but that's kind of the reality that the analyst trying to marshal data has to deal with. And in fact, we call this the data problem because what we found is that analysts are actually spending more time trying to get access to this data and manipulate it and really get it into the form so they can actually do their job than they are actually doing the analytics. And so it's what data assets are available, how do I find them, how do I make sure that the questions I'm asking can be answered by these assets. How do I actually gain access to these assets? Sometimes you have to go through IT, sometimes you can ask your friend down the hall, sometimes you have to go get a subscription to some public data source, get some new credentials. It's a big puzzle, and they just have to kind of put it together piece by piece at a time. And finally, now that I have access to a lot of different sources, how can I actually integrate these sources into a set or a collection of data sets that I can apply to my problem? So this data problem is the heart of where we think that we can provide some value. But before we talk about that, we should probably look at, well, how are people accomplishing this today? So if we take away this and we start to fill in the pictures, the real answer to this is they're doing it in whatever way they can through a variety of mechanisms. And they may be doing some file extracts that they're getting from a friend of theirs who owns the data, or they may be writing some ETL scripts either through the company's ETL technology, or maybe they've downloaded an open source version of ETL, or maybe one comes with one of their tools. And they're probably creating some rogue data marts. In fact, this is one of the problems we see all the time when we talk to potential customers of our technology, is that there are these data marts that people have created all over the enterprise because they just had to create something that met their needs better than the official data marts or official data warehouse that was available to them. And most of the time in these scenarios, they do have to end up waiting for IT in some sense. That's not a ding against IT. It's just that IT's busy and they've got a lot of responsibilities for other data needs like the warehouse and BI reports and standards and compliance and all these things that are a normal part of operating the business. And analytics just becomes one more thing that they have to try to handle. So there's often a queue that they have to wait in. And of course, they don't end up with much reuse. They've got, as I said, maybe they've got 3 or 4 tools, and they have to go recreate the data in each of these tools so that they can get the job done. Very limited connectivity. They probably have pretty good connectivity to relational databases and probably their Excel spreadsheets, but then they got to think about Hadoop and SAP and Salesforce.com, all of which have somewhat unique interfaces. And don't even get started about the public API interfaces for some of these data sources that exist out on the internet. So there's some real challenges around protocols, APIs, connectivity, just to make sure the data can flow. And the one thing that we've discovered is even though the analyst usually starts out working on a problem by themselves, they almost always end up wanting to collaborate with colleagues about what they're working on and potentially share data sources that they've assembled. And it's very hard to do that when you've embedded that in one of your tools or it exists in a spread mart on your desktop. And of course, there's no federation built in, so a lot of this is brute force. So in the end, we've interviewed a lot of data scientists, data analysts, business analysts, and the terms that keep coming up are, this is extremely inconvenient, very time-consuming, and in the end, very frustrating. And so this is a part of their job that we think can be made better. So what do they really want? Well, if you start making a list, it's not that demanding, but it just doesn't really exist in the infrastructure they use today. So the first thing is they want is agility, the ability to quickly create and easily modify data sets to serve whatever analytics they're doing today. They want access to everything. And this is really the difference between how an analyst works and how some of the traditional operational parts of the business works. In the traditional operational parts of the business, you kind of know what data you need and you get that set up in a relatively static and repeatable way. but analysts are always having to reach out and find new data sets, and so they really need access to everything to do their job. They want to be able to create this data set, and we'll start to call these sandboxes, and share those between multiple tools so that you don't have to create a SAS data mart and then can't share that with your Tableau visualization and can't share that potentially with your click view that runs down the hall on your colleague's desktop. So they want to be able to share these with multiple analytic tools. Although analysts are more often comfortable having the data locally, there are a lot of situations, especially now that we're getting more and more cloud and public-based sources, where you need to combine remote data that you might want to leave virtual and physical data that you might be able to bring local. And so you need the ability to actually combine both virtual and physical data in your sandbox. Collaborate with colleagues. We talked about this, and this just isn't at the sandbox level, but being able to share these models that you created across multiple multiple tools, depending on what you and your colleagues are using. Obviously, there needs to be security in place. Now, let's be frank. If I've got data on my desktop that I'm using with my analytic tool, there needs to be less security. But if I want to open that up to 3 or 4 colleagues that work around my department, there probably needs to be some more security to make sure that data doesn't get into the wrong hands and isn't available to people who shouldn't be working with it. One of the things that happens in analytics is you get to a conclusion by assembling all this data, but then you have to try to figure out, now where did this data come from? How did I actually assemble this so that it could solve my problem? And we call that data lineage, the ability to trace back data elements to their source and understand exactly how they were transformed as they moved from that golden source or that original source into the sandbox that I've created to serve my analytic needs. And of course, you need some query optimization. If you're going to have data for doing analytics, especially in the age of big data, especially in the age of distributed data, you're going to need to do some pretty advanced federated query optimization. So this is where data virtualization comes into the picture. Data virtualization is a piece of infrastructure technology that sits between your data sources and your data consumers and creates a semantic layer that allows you to assemble data sets exactly the way you want them to serve a particular need. And in analytics, this is really important because your needs change every day. So the ability to create very lightweight data marts that are a combination of virtual and physical data and do that iteration on those data marts so that you eventually get to the exact data set you need is an important part of how this works. Now, as part of data virtualization, there's an infrastructure that is, we call it caching, but it's a lot more like materialized views that you think of in traditional databases, where you can actually materialize the virtual data integrations that you've created. And so when you're using data virtualization to create an analytic data set, you can actually go and materialize that data set into a sandbox or a virtual mart that now exists in a single database, even if that data came from 5 or 6 different locations. So this ability to not only create very agilely a data mart that exactly meets the need that you're trying to fulfill, but then with one button being able to materialize that mart without having to do any ETL scripts or set up another database or go back to IT and ask for help. It's quite an agile way to create a sandbox for your needs. So I've got I've got my summary points here that it's easier, it's faster, and it's iterative. And these are important points because, again, the analysts are just trying to get to the answer. So I've got a couple of customer use cases here. This is a pharmaceutical firm, Pfizer, which, as you all know, is a very large firm. And they've been using data virtualization for a number of years to augment their data management practice. And the way they augment this practice is by putting data virtualization in front of all of the sources that their analysts may need. And then when an analyst needs a new data set, they work interactively with the analyst to very quickly put together a data set. You can read some of the statistics there on the left, that they essentially have gone from being able to deliver these data projects in 4 to 6 weeks to being able to deliver them in 2 to 3 days. And what's interesting about this is the backlog that the data management team used to have has gone almost to zero. They can respond to these new data requests very quickly. Now, they always deliver these analytic sandboxes virtually first. They will put together the semantic model, they will wire up the data from the different sources, and they will hand that to the analyst and say, see if this meets your needs. And of course, it's usually pretty close to what the analyst needs, but since they asked, there's been some changes, and so now they want to iterate on it a little bit, and so they iterate back and forth, and eventually they get to the data set that the analyst wants. Now, at that point, the analyst will start using the data set, and they will determine whether in its virtual form it's actually usable to do the analytics that they want. Sometimes it is, sometimes it isn't. If it's not responding quickly enough, or they need to do some further transformations on the data to make it more useful, then they can go ahead and materialize these virtual data marts. And they can do that with, again, a touch of a button, and the data mart gets materialized or cached, and now it is essentially, they can connect their analytic tools directly to this virtual data mart, and they can use multiple tools and share the data among whatever tool they're interested in using that day. And it's worth noting that sometimes in Pfizer's practice, they will go ahead and then migrate some of these dynamic, what they thought might have been temporary data marts. They will end up migrating some of that data into their traditional physical marts or physical data warehouse to augment them so that the analytics that was being done can actually be operationalized. The second customer use case I have is from Putnam Investments, again, a very large and well-known investment firm. And what was interesting about their approach to using data virtualization is that they had the rogue data mart problem in spades. Their data scientists, or quants as they call them in the financial space, were very adept at data manipulation, whether they were pulling data themselves or writing some scripts or doing file dumps. They were very good at being able to go and gather the data and even load it into their own database running on their desktop. And so although the analysts ended up getting what they wanted, they ended up having to maintain their own data mart on their desktop. These data marts were out of the control of IT, and so it ended up with a proliferation across the firm of, as I recall, there were hundreds of these data marts. And so the analyst and both the analysts and IT wanted to do something about this, because the analysts didn't really want to create and maintain these, and IT didn't really want the data marts out there in a disconnected and uncontrolled way. So they put data virtualization in the middle, and very much like Pfizer, promised to deliver requested data sets to the requesting analyst in a very short time frame so that the analyst didn't feel like they were being slowed down by involvement of a centralized organization that was doing data management. But the only way they could do that was by using an agile environment like data virtualization. And so they've done this, and in doing this they set up very strong caching data sources where they could materialize these data marts for the analyst to use. And over a period of several years, they've cut down on their rogue data mart problem to almost zero. They will never get it to zero. They realize that. We realize that. But now most of the data needs can be addressed through the data virtualization layer by very quickly assembling these ad hoc data marts and potentially materializing them for the analyst to use. The technology itself is called data virtualization, and what you see in front of you here is the Composite Data Virtualization Platform. And if you look down at the bottom, what you see are a whole variety of structured and semi-structured data sources. And that really defines the realm of data virtualization. It's not actually in the business of processing text-type data where you're better off doing indexing and search, but it is in the business of handling both structured and semi-structured data, everything from traditional relational databases to web services to proprietary interfaces like SAP and to the more modern Hadoop systems and OLAP cubes. So anything that's structured or semi-structured is under the domain of data virtualization. Up at the top, you can see that there's all kinds of usages for data virtualization. If you go into the middle now, that big box in the middle is the Composite Information Server. That's the main runtime product that actually implements all of the metadata management and the creation of these virtual data marts. And also in that big box are the runtime optimizations that allow these data marts to actually deliver the data in a way that will satisfy these analytic needs, even if some of the data is virtual versus actually being local and physical. So of course on the left there's a whole set of development tools. You can use the Studio to create these data marts. You can use Discovery to figure out relationships between different parts of your data. I mean, if you think about it, it's quite easy to look at a single database and figure out what the schema is, what the original design of that database was by looking at foreign keys and some of the metadata. But the minute you get two data sources involved, it's much harder. I mean, maybe there's a drawing on the wall somewhere that somebody has, but most of the time you have to know the data or you have to use some tool to help you discover what correlations exist, and that's what the Discovery tool is there on the left. On the right, of course, there's all kinds of management and monitoring tools that allow IT to understand what's going on in the data virtualization layer and also what requests are being made to the underlying systems. Now, all of this scales to meet the needs of an entire bank of analysts through a shared service by using active clustering. So you can actually take the Composite Information Server and create multiple instances of that with shared metadata in an active-active configuration and serve teams and departments of analysts across different parts of the company. And when you look at large companies like Pfizer and Putnam and others, this is really the key to making data virtualization work, is having state-of-the-art query optimization and the ability to cluster multiple instances together. Okay. So in addition to the Composite website, if you are more interested in data virtualization, there's also a website that we administer and curate called the Data Virtualization Cafe. So if you're interested in finding out more about how it's being used not only for analytics but for other use cases, we urge you to visit us there, and please stay in touch. And I'll look forward to your questions as we go on here. Okay, back to you, Eric.
Okay, I'm going to go ahead and grab the screen back, get our slide deck up, and just give me a second here, Rick, and I will dig up your slides.
All
and
right.
folks, I know we have some good questions in here already, so thank you for that. And let's see, there is Rick's first slide.
Quickly move on.
There you go. I'm handing it over to you right now. All right, it's all you.
All right. I can actually move it. Great. Well, hello, everyone. So we'll look at a little bit perspective on some better ways to fuel analytical needs with the context of business analytics and data integration. And even though, as Eric, as you mentioned, that integration sometimes is downplayed, certainly with the onslaught of data that we have, it's front and center. All right. There we go. All right. So to take it a little bit from the perspective of analytics, right now we're in a data tsunami. I didn't want to use the word big data until at least a small bullet line there, because we're inundated with that phrase. But regardless of whether you have big data or small data, the amount of volumes, the variety of data that you're encountering in an enterprise, and the velocity, the speed at which the data is being updated is increasing. Whether you're small, a medium-sized, or a large enterprise, all those three V's are drastically increasing, especially over the last few years. Now, coupling along with that, and the reason why it matters, is because the analytics complexity is also growing. the business use, the enterprise use of information and analytics has been expanding in recession and in boom times across all different industries for many business uses in healthcare across the board. It's expanding and exploding. Going along with that, the types of analytics, we've gone from simply year-over-year and trending analysis into much more sophisticated advanced analytics with the categories of predictive analytics, data visualization, and data discovery, previously called statistical analysis and data mining, etc. But these are areas that are creating great business value, and those are the space where the data scientists that David mentioned earlier are working. When I first started working with folks doing these analytics, they weren't called data scientists, but now it's a new role that a lot of people are talking about. And beyond just the predictive analytics and the data scientists, BI needs to be more pervasive across enterprises today, with business people being able to get the data, look at the information, and do analysis. So it's not just the data scientists out there. It's not just the business power users, but it's business people from all sorts of processes and line of businesses within an enterprise. Now let's look at sort of why we're sort of stuck right now with business analytics and data integration. The first of these four pictures is the large IT queue line for your reports. This process, the backlog, has been significant for years. Now, it isn't just, and this is one of the things I emphasize with people, if you have a huge BI backlog, it could be because you're not doing a good job. But actually, the enterprises that have been doing the best job are the ones that have the biggest BI queue, and that's because they've been able to successfully deliver data and information. But whether you're whichever end of the spectrum you're at, the need for information and for analytics is growing way beyond what the normal IT staff can do. Now, the second one is being stuck in the mud, and one of the things that's happening is that the queue is getting larger and larger. The data sources and varieties is expanding. But our current processes and architecture don't seem to be able to handle that well. We use the term sometimes Agile or iterative development, but our processes really aren't there. One of the things that's significant is the fact that I think it's Forrester had talked about something like 80% of the BI requests that go into a queue never go into production in the BI space. The reason is because 80% of the requests are either exploratory or one-time analysis. Something's happening in a particular line of business with a product, with a particular large account. Somebody's trying to do some analysis for it. That gets into the queue. When we go back in the previous diagram, if 80% of the requests don't go into production, is there any way we can handle that a little bit differently? We're sort of stuck also in sort of binary decisions when we get to how do we place our architecture. We have to have BI in the data warehouse. We have to have data integration based on ETL, and our operational systems are all silos, which gets us to the next diagram, which is if there is a long queue, if we can't meet demand, then what happens is specifically what David said earlier, is we end up with spread marts, data shadow systems, rogue data marts, whatever you call them. We have a lot of data silos. And more of the new data that's coming into enterprises are being added to those silo processes. And the last one, hopefully it's not a picture of me from high school, but it's just a picture showing that our current methods and our current approach requires a lot of skills, specifically in the extract, transform, and load data integration space. And is there a different way in order to be able to change that so we can expand what we do, move more faster, and be able to meet the analytics demand? Let's talk a little quickly on some of the changes. Now, we've seen an expansion in business analytics area where we have more and more different BI styles that are out there. Data visualization, data discovery, OLAP, et cetera, dashboards. One of the things that I don't think has been really recognized is the fact that there are, not only do we have a portfolio of BI styles and BI products, we also have a portfolio of data integration styles. And I'm not so sure if people always recognize that they're in fact different integration styles. So We have extract, transform, and load. That's a bread and butter data warehousing, the batch-driven processes. That's changed, but to a large extent, that's sort of what people think. We have database access. We have SOA or data or web or data services. But the area we're talking a little bit about today is the data virtualization. So if we're looking at, do we have to move data? Do we have to set up services? Or are there other alternatives so we can move or access data or see data or link data together without actually physically moving it? And that's the space of data virtualization, which Composite's been talking about. And then second, and we'll get into this in the next slide, is we have our usual data stores, but we also have an analytical sandbox and some other data stores that we can use to increase analysis. This gets us to this slide. And I think besides the analytical sandboxes, there's also exploratory data marts. So let's talk first about analytical sandboxes. So the ability for a data scientist, somebody producing predictive models or advanced analytics, needs a space to be able to drag in data, not only from the data warehouse, but also from other sources, semi-structured data, data from other operational systems and other data silos together to do more complete analysis. As they talked about, people doing advanced analytics need a lot of tools, and they need a whole lot of data from a whole lot of different sources, and it's an iterative process. So if they had to be in the IT queue to meet the demand of their data, they'd never get things done. That's the reason why they create sort of their own rogue systems and pull data from all over the place. If we can somehow speed it up, create an analytical sandbox, leverage different data integration technologies, specifically data virtualization, in order to speed up and enable the data scientists to examine more data and produce better models. The other one, which is in orange, is the exploratory data marts. Besides the data scientists, we also have business power users and actually many analysts who are very, very data savvy, who are also doing the same thing as far as pulling data from a lot of different sources. They're not maybe running statistical models against them, but they are pulling data from a lot of different sources, many of which aren't in the data warehouse yet. And so enabling them with exploratory data marts using data virtualization as well as other data integration techniques would vastly improve their productivity. Forrester's talked something about over a quarter of the time of the typical business analyst is spent in just gathering data. And a data scientist, I'm not sure of what the study is, but just based on working with many of them in different industries, it's probably about half their time is spent in just gathering data and not doing the model. So being able to speed that along and enable their activity would quite help the system. Finally, just some final thoughts. So we need to be able to enable business analytics, advanced ad hoc analysis, and self-service BI. We need to support data variety, velocity, and volume. And the enabler to do that is by increasing and expanding our data integration portfolio. We have data ETL. Many companies have data services, and we need to expand it as part of the portfolio to have data virtualization. And as the New York Times article said, that's when the data guys triumph. Eric?
Okay, you can just start asking questions now and let the briefing begin.
Okay, great. So David, Eric started off by mentioning data federation and data virtualization, and also an old term was EII. One of the things in my travels with customers, prospects, and in training, people are always confused by this terminology. Are they the same? Are they different? What's the answer?
Yeah, it's a really good question that we get often, and I think data virtualization is different, more encompassing than data federation. I think data federation is an important part of data virtualization, but data virtualization is really the entire concept of creating an abstracted semantic layer to access all of your structured and unstructured data that provides decoupling between consumers of data and the sources of data. And that's valuable even if you're not doing any federation. That's valuable even if all of your data does end up being consolidated into one source. Now, data federation comes into the picture because oftentimes the motivation for starting to use data virtualization is the fact that your data is not all in a single place and well structured for a particular problem that you're trying to solve, and so data virtualization can solve that by using its data federation. but what we found is over the long term, our largest customers get as much or more value out of the semantic layer and the decoupling and flexibility that that provides as they do out of the data federation capability that's built into the virtualization.
Excellent. I'll make sure my students give that answer next time I quiz them on it. Going along with the semantic layer, and I agree with you, that's pretty invaluable. The other area that I get questions on that's a little bit confusing is that some of the BI tools also have a semantic layer or repository, and they've pitched that for a while. What's the differences between what Composite provides as well as what BI Suite X or Y will offer as a semantic layer?
Yes, and conceptually they can be similar, especially if you're focused on your particular tool of choice. If we talk about some of the things that data virtualization does, you could potentially say, well, I can do that in my Cognos layer, or I can do that in my business objects layer. And to some extent, some of the functionality is there. But there's two really important reasons that you really shouldn't be doing that. One is the idea that this form of data integration, being able to virtually bring together multiple sources and create a semantic layer, is really hard. We've been working at it for 10 years. We have a very sophisticated product that solves customers' problems. And these implementations of this similar functionality in the business intelligence and visualization layer is just not as sophisticated as what you have in a dedicated data virtualization layer. A second, but probably even more important reason, though, is if you do data integration and modeling in your tool of choice, you have essentially tied yourself to that tool in order to use those definitions, those canonicals, all of the work that you've done to create the ideal data set. You now have to only use it in that tool. One of the things that data virtualization provides you is the ability to do this work once, to create really interesting, really business-focused data integrations, and reuse them with multiple tools. So you can use them from your Cognos environment as well as your Tableau environment, as well as from SAS and Spotfire. And everybody ends up using the same definition of that data set so that you don't get to the meeting and have different reports reporting different numbers. So again, sort of from a operational and technology standpoint, a data virtualization layer is going to be better at solving this problem. But from an architectural and reusability standpoint, it's also the right way to do it to get the most value out of your data in the long term.
Right, and that makes a lot of sense. And I haven't met a customer yet who doesn't have a half a dozen BI tools that were at one time or another the standard.
The standard, exactly.
Right. And going along with that, the semantic layer and doing that work once, one of the things that one of the processes that's hyped, but also one of the more valuable things that people can do in data management today is data governance. Now, how does that fit in with data virtualization?
Yeah, and you're right that as data gets more and more complicated and more distributed, governance is becoming more and more important because you don't have all of your data in one well-formed data warehouse, and so it is harder and harder to have good governance and good stewardship. So I mentioned a couple of concepts during my part of the talk, things like data lineage, things like metadata, and as a platform in your infrastructure, data virtualization supports good governance by keeping all of this data that's flowing to the consumer mapped back to the original source where it's maintained. And so you have very good tracking and lineage for how this data gets transformed as it moves up the line and finally into the actual usage. You have very good visibility into who's using this data and how it's being used and how often it's being used. And you have very good manageability for iterating on and maintaining these reusable canonicals. I mean, if you think about one of the goals we've had in data management for, gosh, at least a couple of decades, it's to get to a very well-managed set of business data definitions. But it's always been very difficult because we've been trying to do that by physically instantiating them into yet another data management container, like the data warehouse. That's hard, and companies have actually gotten a lot of great value out of the data warehouse, but one of the places where it's been hard for them to get the full value is to finish defining that semantic definition of their business. It will just never be finished. So this all goes along with governance. If you can do that kind of data definition incrementally as part of a virtualized layer, you're going to have a much better chance of moving your set of canonicals through good data stewardship and good governance towards a complete set of reusable components that really does define the data definitions that your business wants to be run on. And ultimately, that's one of the main goals of governance, is understanding what is our business data and where did it come from.
Okay. And I think you sort of alluded to it in your recent answer, but one of the things that intrigued me is sort of the usage and monitoring that you have in your architecture. So what is that really exposed to somebody doing data management and actually operating BI operations?
Yeah, I mean, if you think about traditional data sources, they always have tools that allow you to see who's running queries and which queries are taking a long time. When you go to a virtualized version of this, it just gets more complex, and you do need very good tools to have visibility into what's going on the virtualized infrastructure. So we provide runtime tools in the form of a manager tool and a monitoring tool for both the data management team and the operations group to see what's going on, what requests are being made, what requests potentially are impacting certain underlying systems, how many users are currently in the system. All of that's available through a set of dashboards and control centers that we provide as tools. In addition, kind of being the Switzerland of data, we have to sit right in the middle of everything that's going on around us. So we also make all of that metadata and governance data and monitoring data available through APIs so that you can either write your own tools if you want to, your own monitoring rules, or you can also integrate with an existing operations environment that may use SNMP traps. We can expose those. So there's a lot of hooks in and out of the system to expose exactly what's going on and how all of this metadata or virtually integrated data is being used.
Excellent. Going along with we were looking a little bit about the different types of data integration, and I saw again on your architecture you had some things related to data services in the lower right-hand corner. So how do you interact with services, and how does that play with various tools?
Yes. So again, going along with the theme that data is getting more diverse and more complex, as a result, we need to be able to work with a lot of different protocols. And this is true both on the source side, so being able to access data services both as SOAP or as REST, and also on the published side or on the consumption side, being able to make data available, say, to a business intelligence environment. It can look like a virtual database, but to a enterprise service bus and the people who are creating business process flows, it can look like a collection of data services. And one of the things that a advanced virtualization platform does is allow you to create these canonicals in the middle and then publish them in multiple forms so that consumers can consume them in whatever way makes sense. Again, we have customers who use the same data definition to query from their analytic tools and to invoke services from their business process flows that they've built in their app server and on their ESB. So you have to be able to expose and consume services just like you can expose and consume traditional relational data. Now, it does present some interesting challenges in the middle when you have data of different shapes and different semantics. And to handle that, we provide a number of transformations that allow you to cross these boundaries and combine data of different types and shapes into other data of different types and shapes. And all of these transformations have their own ideal language that they work in. If somebody's working with a traditional relational type data set, they're probably going to want to work in SQL. If they're working with XML data set, they're probably going to want to work in XSLT or XQuery. And you can do that in a virtualization layer and then reuse an XSLT implementation as part of a SQL query. And so all of these different data manipulation languages and methodologies need to be able to work together inside the virtualization layer to give you the best tools so that you can expose the data just the way you want it.
Oh, excellent. Eric, I can see a lot of good questions streaming through. Do you want to put
I'll go ahead
and David?
Sure thing. So great presentation, by the way. That's a lot of good questions right there, and a lot of really good just good information. So we got a whole bunch of questions here. I'll just start at the top. First come, first served. So David, I know that you guys do have some kind of a methodology you use to determine ROI. Can you, one of the analysts or one of the people in the audience asks, can you quantify the ROI generated by the composite approach versus a classic approach?
You can, and in fact, we have a small team at Composite that's actually all they do is over the last half a decade, they have worked with our customers to understand the dynamics of how data virtualization has actually saved them money and returned on their investment. Now, it actually has a lot of different factors to it. I'll just describe a couple of them. And if you're interested in going deeper, we can definitely get more information about our methodology. But a couple of examples here are time to market. So in a traditional data integration methodology, you would generally use an ETL type approach, and you would set up a data mart or even a data warehouse, and you would have a project. And those projects typically take 3 months to multiple years. When you use data virtualization, it's a much more agile approach, and you have a much quicker line to actually being able to use the data, and you get to iterate much more often so that you actually solve the problem. So that time to market almost always ends up being the difference between whether you have paid for this technology or not. So in addition to that, there are infrastructure costs that you might be able to redistribute or displace based on the fact that you no longer need to create so many replicated copies of data. We talked to one customer who the database vendor shall remain nameless, but I walked in the room and essentially their statement was, I have a lot of data, but most of it's because I've been copying it all over the place, and I'm really tired of writing really big checks to XYZ data company. And so part of what they wanted to do is reduce the number of replicated copies of data, and using virtualization, you have a good opportunity to do that.
Okay, good. And let's see, moving right along. So we already did this one. Okay, so another attendee asks, is there any way that composite software can minimize the performance impact of aligning massive data sets across multiple sources? I mean, I think that's right in your sweet spot, right?
It is. And to be honest, that is the big question when it comes to data virtualization. It's usually the first one on people's minds is, can this really work? And to answer that question, honestly, I could talk for 2 or 3 hours on this. I do it all the time with some of our deeper prospects. But let me give you some of the highlights. The first thing is, when you use virtualization to access your data, it's not an all or nothing thing. It's not that yesterday you had a completely consolidated source and today you have a completely virtual source and you're going back to the source systems. Because you have the ability to do caching and to integrate not only source systems but also pre-consolidated systems like your warehouse and your marts, in actuality, your virtualized data access ends up being quite a hybrid mix between physical and virtual data. So it's not all live data all the time. You can do that if that's what your need is, but in pragmatic sense, it's usually a mixture. Secondly then, and this is where our sweet spot and our core intellectual property lives, is the ability to take that metadata definition of the virtualized data set, which probably includes some pre-materialized data, but probably includes some live data, and optimize those requests to run them as fast as they could possibly be run, given the fact that you're going to move a certain amount of data over the network. And so what we do is we try to push as much data reduction down to those sources so that we reduce data in the source. We try to run joins in the right order so that the small data set is being moved instead of the large data set. We try to prune columns and push down constraints and eliminate redundant operators. All of this gets done in a matter of milliseconds as part of our query optimization, and it makes a huge difference. I'll give you one example of an advanced join technique. It's called our data ship join. And in a data ship join, say you have an Oracle data source and an Athena data source, and you need to do a join between a table that has hundreds of millions of rows and a table that has over 1 billion rows. If you just did that brute force, you'd have to really go out to lunch and maybe come back at the end of the day, because moving all that data across the network, doing a federated join, it's just not going to respond the way you need it to. But if what you realize is that the half of the join that's going to the hundreds of millions of rows of data is really going to produce, say, I don't know, 2 or 3 million rows, and you then take that 2 or 3 million rows and you move it over next to the billion row table by creating a temp table, moving that much data using bulk extracts, bulk loads, and then running the join down in the Netezza platform is going to produce very responsive results, even though you were dealing with billions and hundreds of millions of rows of data. But that kind of advanced join strategy is something that we've worked very hard on over the last decade to continue to advance.
Okay, good. And thank you for that very specific example, too. That definitely helps. Here is a rather complex question, and I'll be curious to hear the answer on this one. One of the attendees writes, usually coding for reports has to be done in a serial fashion after the data has been integrated and all set up. Could data virtualization be a way to parallelize reports development and data integration development?
Well, I think that's probably depends a lot on your practice with your business intelligence reports. In a lot of ways, the way that we can speed up the delivery of BI reports and analytic uses is because a lot of the data sets get reused over time, whereas oftentimes you're ending up creating new things each time you're creating a new report. If instead you can point your BI environment to a set of data canonicals that already embody what you need, and you don't have to do as much data integration up at the BI platform, that's going to help. Now, on the question of serialization versus parallelization, I think it really depends on the dependencies between the data. I talked about serialization of joins versus parallelization of joins. Very similar thing in reports. If you have a report that's going to show some kind of aggregated data with some summary data, and then you're going to have a report that shows the detailed data, you're probably going to have to create both of those data sets. And you're probably going to want to create the detailed data set, assemble the detailed data set, and then do the aggregation on that set. Whether you do that in the BI layer or in the data virtualization layer, it's probably still going to be a serialization. But at the end of the day, you can decide to do one of them virtually versus physically and potentially end up with some time savings. So I think it depends on the relationship between the reports and the dependencies there. But because you end up with this very agile environment, there's certainly the opportunity to do some things a little bit differently.
Okay, good. And here's an interesting question, kind of more of a general question. One of the attendees asks, algorithmical versus statistical analysis, are they complementary or opposite methodologies?
Well, you're probably going to start to exhaust my analytic knowledge here. I think in talking to the data scientists and analysts that I have spoken with, there are at least those two and probably several more classes of analytics. You know, it's funny because we used to say that the difference between BI and analytics was reporting on operations, reporting on what happened, versus trying to figure out what's going to happen. But it's not that simple. Sometimes you have a question that you have on your mind, and you're trying to answer that question or prove whether that question is true. So it's a very targeted approach. In another time, you actually don't know what you're looking for, and you're doing exploratory analytics to try to find some new insight that maybe you haven't thought of. So I think that there's a lot of different domains and approaches to doing analytics, and those are probably just two of them.
Okay, good. And here's another very specific question. You talked about cached, how you will cache certain data sets. One of the attendees asks, does cached mean in traditional tables, in disk-based systems, or actually in memory, or some other kind of proprietary storage?
Yeah, it's a really good question. And in fact, one of the reasons that we worry sometimes about using the word cache is because we do get confused with some of the in-memory object caches. So let me be very clear. Our caching and data virtualization caching is very much like materialized views in a traditional database. Now, it goes a little further than that in that it doesn't just have to be relational data. You can also do procedural data, so you can cache web service results and stored procedure results. But at the end of the day, it is a materialized version of whatever set of data this is. Now, you can store that in a number of places. Most of our customers will store that in a traditional data management environment like a Oracle or Teradata or Netezza. And in doing so, it ends up on disk just like any other table does. But more and more of them are starting to use in-memory versions of these technologies to actually pin these tables in memory or actually use an in-memory database to do the caching. So it's still distinct from the in-memory distributed object caches that you might get when you're working with an app server and trying to cache, doing a first in, first out, or least recently used cache. But those approaches are complementary to the data virtualization caches.
That's very interesting stuff. That's very good detail. Okay, just a couple more here, but really good ones. Let's see, another attendee wants to know, bouncing off of Rick's question, and according to what you, David, had explained, how does data virtualization integrate MDM? And then he goes on, but how does one connect the data to the metadata that have been defined in the virtualized layer, like in the materialized views?
Yep. Really good question, because MDM is obviously something that a lot more companies are taking advantage of in trying to create good data stewardship and good governance for the master data that they do own. Data virtualization is very complementary and, in fact, turbocharges master data management in two ways. Let's take the operational way first. You've worked very hard on your master data management hub, and you've now got your master data sitting there. And the first time you go to use that master data, inevitably, you will have to combine it with other data around the enterprise. Because by definition, you didn't move all of the data associated with customer into the master table. You moved information that allows you to go find data about this customer and integrate that data with some common keys, but you don't actually move 360-degree view of customer into the master data hub. So data virtualization allows you to actually leverage your master data management system to actually get value out of it by doing federated joins between your master data system and your other systems. So that's kind of the long-term architecture that you end up having in place. Now, while you're creating your master data management system, data virtualization is often useful to actually help you marshal the data and I hesitate to use the word cleanse, but in some ways that's what you're doing, is try to format and enrich and get the data into the right form for actual use in your master data system. Data virtualization can also help with that, almost as an agile data access mechanism. But that's more when you're creating the metadata than when you're using it.
Yeah, that's great stuff. Okay, good. And let me see. I know there are a couple more in here somewhere. These are really, really good answers and good questions, so thank you very much. So let's see. Perhaps one more we'll throw out. And folks, if you feel a question you asked was not answered, feel free to follow up, and we'll definitely get someone in touch with you. So let's see, how is dynamic or distributed SQL, how is that handled? What about joining in a query, calling cubes via MDX, and joining with relational databases, et cetera?
Yeah, good question. Because I've talked a lot about relational data or tabular data and hierarchical data, but I didn't spend much time talking about multidimensional data. There's a couple of places where data virtualization doesn't make a lot of sense to slide in between the data source and the tool you're using to access the data. And one of those is generally with the multidimensional data, where there's usually a tight coupling between, say, Hyperion and Essbase, or between SAS and its cube MART, or even between Spotfire and its in-memory cube. So you wouldn't really want to slide data virtualization in between that tight coupling. But those cubes that are created, that multidimensional data that exists, say in SAP BW or in an Essbase, you may want to use that data outside of that tightly coupled tool and augment some other data with the multidimensional data. And so that's the approach that data virtualization takes. We allow you to access that data, but when you do access it, you actually create and define what slice of it you're accessing so that you can combine it with the other data you're using, which is likely to be relational, might be hierarchical, but it's usually more convenient to end up with a slice of that cube versus the whole multidimensional. So, and just to be clear then, multidimensional semantics in their full form are not part of our data virtualization layer. But we can access multidimensional data from a variety of systems so that you can integrate it with some of your other data.
Okay, good. And let's see, is there anything else? I think I got to just about all of them. Yes, I think so. Well, folks, here's one. This is kind of a curveball question here, and I realize you may not have come across it. I'm not sure if Composite Software has any clients in the sort of environmental or agricultural industries, though I know you do certainly have a lot of clients in oil, right, in the energy industry. So one of the attendees asks, it's clear that the secret sauce for big data, BI, analytics, and so forth are algorithms. Are there any open source algorithms that can be applied to some of these more complex industries like agricultural production and stuff like that?
Oh boy, I'm sure there are. I've talked to a couple of our energy customers about not only some specific data types that they have, but also specific algorithms they have for manipulating them. I'm not familiar with the specific ones that they use, but I'm quite certain there are lots of open source industry-specific tools for manipulating your data. I mean, one of the things that is interesting about part of this question is there are also unique data types like geospatial data, and in pharmaceuticals there's molecular data, and that data all has to be passed through the data virtualization layer as well. Now, we don't manipulate that data because semantically it's out of our scope, but we are able to pass that data through so that if you have algorithms that you're using to work with that data, whether you're getting that data out of your source system or through the virtualized system, you should be able to use it.
Okay, good. Well, folks, a lot of great questions. Thank you so much for all those good zingers. We love when you have the good questions out there. It makes my job a lot easier. You can see that integration is still the topic for this month. We have 2 more webcasts lined up, Jaspersoft and then the company called Ideate, which has some very interesting stuff coming up. October is database, then cloud, and December is innovators. January we have listed as architecture. We get so much demand for big data that we might actually switch that to big data. But keep your eyes and ears peeled for what's coming up next, folks, and we'll hope to catch up with you next week for sure. Big thank you to Rick Sherman for his time today, and also to our friends from Composite Software. They always do a great job. So thanks again, folks. We will archive this webcast. It will be at insideanalysis.com under the webcasts section. Look under Briefing Room, recent episodes, and that is going to be it for today, folks. Take care. Bye-bye.